Good day everyone. We will discuss about finding transaction latency in an always-on synchronous replica. Let's get started. I'll be using this particular environment for this video. The Windows cluster would be JBS Wiki cluster. We have an always-on availability group called JBS AG, and we just have only one database added to this AG, which is JBS Wiki. We have three replicas, two replica in East US and one replica in Korea Central. So all these three replicas, JBS AG1, JBS AG2, and JBS AG3, are using synchronous commit. So don't get confused with the color as far as these lines are concerned. All these three replicas are configured using synchronous commit mode. So let's go to the server and let's refresh the always on availability group dashboard. And if you can see here, we have three servers as updated earlier. It is JBS AG1, JBS AG2, and JBS AG3. If you remember, JBS AG1 and JBS AG2 is in East US and JBS AG3 is in Korea Central. And if you see here, the availability mode is synchronous commit. So JBS AG1 is currently the primary replica. And as far as the failover mode is concerned, JBS AG1 and AG2 are having an automatic failover mode, and JBS AG3 is having a manual failover mode. One thing to understand is like there will be a huge latency from US to Korea Central because they are geographically separated. So just for this demo, I have added JBS AG3, which is in Korea Central, as a synchronous secondary, just to showcase like as far as the latency is concerned. Okay. So now what I'm going to do, I'm logged into JBS AG1. Let me ping JBS AG2, the secondary replica, which is in East US. And if you see here, like the ping response is basically 1 milliseconds. Everything seems to be okay, at least on the ping response. I'm able to see like in one instance, it is close to 2 milliseconds. And if we look at it here, minimum is 1 millisecond and maximum is 2 millisecond. Now let's do the same thing for the Korea Central server, which is JBS AG3. And if you see here, it is no longer 1 millisecond, it is 185 millisecond. So just want to show, at least as far as this particular latency is concerned. If you see here, as far as East US is concerned, it is just 1 milliseconds. For Korea Central, it is close to 185 milliseconds. So definitely there is a latency between JBS AG1 to JBS AG3. Yep. So now what I'll do is like I will perform a simple insert on the primary server, which is JBS AG1. It's a simple insert, like it's not going to be a hi-fi insert, just like an application, which basically puts in a lot of data in different tables. Just for showcasing the latency, I'm just going to insert data into one table. I'm basically inserting close to 100,000 rows. Yeah. So let's start it. First thing that we will do is like we will check sp_row is active, and then see if this SPID 67 is waiting on something. So what I'm seeing is like I'm able to see that we have an HADR sync commit, which basically tells like the time taken for the sync between the synchronous replica, and the wait time that I'm seeing here is close to 159 milliseconds. So which is somewhat similar to what we saw when we pinged. It is not same, but that is what I'm seeing. So let's execute it a couple of more times. So 105 milliseconds, 132 milliseconds, 70 milliseconds. So what I'm able to see is like we have HADR sync commit issue, wherein when I'm trying to perform a simple insert, I'm able to see like definitely we have some sort of latency. For every insert, we are spending good amount of time, like close to 100 to 200 milliseconds. So let's execute a couple of more times. 151 milliseconds, 47 milliseconds, 92 milliseconds. So basically we are seeing like each of these inserts is definitely waiting on HADR sync commit. Again, this wait type is basically for databases that is participating in availability group, that is always on availability group. when modifications occur on the primary replica in a synchronous mode, it must commit all of these onto the secondary replica before committing on the primary. So this wait type is basically accumulated during this wait period when the changes are basically hardened onto the secondary, and then it waits for the acknowledgement from the secondary before it sends an confirmation to the client that it is all committed, and then that is how the always on availability group works. So you can look at how always on availability group synchronous and asynchronous commit basically works. I'll put in a clear information like how each and every step happens and how does the data that is getting inserted on the primary is basically sent across to the secondary. But as far as HADR sync commit wait type is concerned, it is basically the wait time till whatever data is sent across from the primary to secondary is hardened onto the secondary, and then it basically waits for that acknowledgement. So the whole process, that is what is mentioned, that is what is referred to this wait type HADR sync commit. So let's execute a couple of more times. So we are clearly seeing like we have a wait type of more than 100 to 200 milliseconds. So now what we'll do is like we will try adding a couple of counters in performance monitor, and then we will check that further as far as your latency is concerned. So now we have this mirrored write transaction under slash seconds. Basically, it is on SQL Server database replica. If you see here, it is under SQL Server database replica. So first, I'm going to add this mirrored write transactions per second. I'm going to select the JBS Wiki database for this one, and if you look at the description, it basically tells like number of transactions which wrote to the mirrored database in the last second that waited for the log to be sent to the mirror. Okay, this is what I'm going to add first. And after this, what I'm going to do is like I'm going to add something called transaction delay. And if you look at the description, it is basically telling like number of milliseconds transaction termination waited for acknowledgement per second. So this is the actual transaction delay. So I will add that one as well. And then now what I'll do is like I will change this to report, and what we can see here is like write transaction per second. So basically like kind of close to 5 transaction is reaching across to your secondary, and the transaction delay is basically like this much in milliseconds. So what we basically have to do is like we need to divide the transaction delay by the mirrored write transactions per second, and whatever is the value is basically is your latency. That is the value that is maybe like it can be equated to the HADR sync commit wait time. So what you have to do is like you need to divide the transaction delay by your mirrored write transaction, and whatever value you get, that's your HADR sync commit wait time. Yep. So let's pause that, and then what I'll do is like I will open a calculator. And then what we can do is like we will divide 902 divided by 4.9. So what I'm seeing is like we are getting close to 184 milliseconds of delay. So if we see here, that is exactly same as what we are getting when we ping. This is not an exact representation, but at least I'm lucky wherein I'm able to see like there is a delay of like that ping response is like for every ping it is 184 milliseconds, and exactly I'm getting the same thing in the performance monitor also. So this proves like whatever calculation that we are doing seems to be the same. So basically for each transaction, for each and every transaction, we are basically waiting close to 184 milliseconds. Not a good sign. So now what I'm going to do is like I'm going to increase the delay. I'm going to use a tool to basically bring in some sort of a delay as far as the network is concerned. So what I'll do is like I will put a maybe like close to 3 seconds of delay, and once I put in close to like 3000 milliseconds, which is 3 seconds. we will check the transactions again. Yeah, the transactions are running there. So I have put in like 3000 now. So it is started. So now what I'll do is like I will first what I'll do I will do a ping now. So right now we are seeing 184 milliseconds. Let's confirm if we can see a delay of close to, already we have 185 millisecond delay. So now I have put in 3000 milliseconds. So that means like we should see something around 3185 milliseconds. Let's look at it. So if we see here, it is basically showing us 3212. So whatever we have done is definitely reflecting here. So I have added close to like 3 seconds delay. Again, this is a demo environment, so I'm doing all these things. If you have a demo environment, you can try all these things, but on production, it's a strict no, you can't do that. So since it is a demo environment, I'm doing all these things. Now what I'll do is like I will make sure the transaction is running. Okay, the transaction is definitely running. So now what I'll do is like let me run sp underscore who is active again. Now if I see, oh, it is showing as HADR sync commit. Now it is definitely increasing more than 200 milliseconds, 1208 milliseconds. 1061 milliseconds. So we are able to see like the HADR sync commit wait time has drastically increased. Now what we'll do is like we'll look at the actual picture. So whatever we are doing, it is all based on the time when you're hitting the execute here. So there is no way you will be able to capture the information. But if you follow your performance monitor, you will be able to get the details exactly. So now what I'm seeing, I'm able to see like if you see here, I've just passed it. Mirrored write transaction is like 1, which basically tells like for every transaction, I'm able to see a transaction delay of this many milliseconds. Okay, so now what I'm going to do is like I will do the same calculation. I will divide the transaction delay, which is 3205.8 divided by mirrored write transaction, which is 1.008. And if you see here, we are getting an latency of 3 seconds, 3.18 seconds. And if you look at the ping response here, what I'm able to see is like it is somewhat similar. So it is 3180 in the performance monitor, and here we are able to see like close to the minimum is 3189 and maximum is 3200. So this is a kind of an easy way to understand the transaction latency. You can on the fly when you see an HADR sync commit, what you can do is like you can open the performance monitor and then you can have a look like what is the current latency. And one more thing that you can do is like I usually prefer this method. Even though performance monitor is a handy tool, you can have a look. But if you want to schedule this one, so what you can do is like you can use some sort of T-SQL that I have created, so you guys can use that one as well. So what I'm basically doing is like on Tempdb, I'm creating it on Tempdb, but after the SQL Server restart, you will lose all the data. You can put it on user database, maybe in DBA related database, and then you can store it. So what I'm basically doing, I'm creating a table called Perfcounters. I'm having 3 columns initially. Captured time, basically it tells like at what time this data is captured, and then I'm adding this transaction delay and then the mirrored write transactions per second. After this, I'm creating a computed column, which basically what it does is like it basically divides your transaction delay by mirrored write transactions per second. Okay, let me execute this. Once this is done, what I'll do is like I will create an I will execute this particular query. Let me show you what I'm doing. So what I'm basically doing is like I'm using a while 1 equal to 1. Just for this demo, I'm going to run this and then I will close it off. And you know, like I've created everything on Tempdb. But in case if you are creating this on an a user database, then what you can do is like you can remove while one equal to one, and you can put this information till this onto an SQL agent job, and then you can schedule it once in 10 seconds or once in 1 minute or whatever you guys feel would be better for your requirement, and then you can schedule it. And if you want, you can try this one as well using a while one is equal to one. And I have a transaction delay of for every transaction it is 3 seconds. I'm adding a wait for delay. So let me start that. So let's allow this to run for say like 20-30 seconds so that we have some data. In the meantime, if you look at it, what I'm seeing is like basically each and every transaction is waiting for 3200 milliseconds. That is 3 seconds. So that means like each insert without always on availability group might be completing in say 10 or 20 milliseconds. For moving this 10 or 20 milliseconds insert that happened on the primary to your synchronous secondary, I think like whatever you're trying to move to JBS AG2 is all good because both are in East US. But when you're trying to move that to the third replica, which is JBS AG3, which is on Korea Central, and we have added an extra delay also using that tool because of this 10 seconds insert without availability group. With the availability group is basically taking 3 seconds, yeah, 10 milliseconds, sorry, 10 milliseconds insert on the primary replica without always on availability group is now basically taking 10 milliseconds plus 3.2 or 3.3 seconds, since we have this always on availability group. So this is something that we need to take into account, like before implementing always on availability group into production. It is better we do the proper testing and understand the transaction delay. Make sure like we are not opting for a synchronous replica, which is like kind of geographically separated from your current primary. You need to do all these testing, make sure it is suiting your requirement, and then move forward. So right now it is running for like close to 2 minutes. So now what I'll do is like I will click on a new query window, and then I will basically execute this particular query. What I'm basically doing is like I'm just selecting all the data from Perfcounters, and then I'm ordering it by the captured time. So if I execute it, I don't see anything as of now. Let's look at what is happening. Okay, my bad. So I'm not given the right database name. So let's stop it. And then you need to put the database name. So in my case, my always on availability group database name is JBS Wiki. So let me start it one more time. It's going to take some time. So yeah, we have this delay, just making sure like it is not completing. Okay, now what I'll do is like I will let this run, and then let me execute this query. And now if you see here, what I'm able to see is like I'm seeing a transaction delay of this much, and then mirrored write transaction is this much. And what I'm basically seeing here is like I have a transaction delay of 376 milliseconds. So the problem with this method as far as T-SQL is concerned, this value that we are seeing here is basically a cumulative value. It's not a point in time value. So what happens is like whatever information that gets into this particular counter is basically cumulative when you place it on the table. But if you directly look at the performance monitor, you will directly get the information. It's not a cumulative value, it's a point in time value. Whatever is happening at that point in time, you will be able to get the information. So that's the difference, like what happens when you use the performance monitor directly and then use a TSQL like this. Yep. So let's execute it one more time, and we are able to see that we are seeing an average transaction delay of close to like 398 milliseconds. That's what we are seeing for each transaction. It is the cumulative value is showing us 398, but when you look at the performance monitor, we are able to see that we are getting a transaction delay of close to 3 seconds. So now what I'll do is like I will go back to my server and then stop this tool that is basically adding that 3 seconds delay. Yep, it is kind of stopped now. Okay, it is stopped now. So now what I'll do is like I'll go back to JVS AG1, and then now if you see here, the delay has come down. Like it is now close to like 200 milliseconds. It is no longer 3 seconds for each transaction. Now, if you look at the data here, what I'm seeing is like, if you notice here, it is basically increased from 398. We were at this one, 384 or 385. Now it has increased to close to 400 milliseconds. So basically, it gives you an cumulative information here for this particular table. The real information that you get is using the performance monitor, because this is a point in time information. That is, whatever is happening right now, you will get it. But the T-SQL that we are using here is basically a cumulative value. So it basically adds up on all the information that has happened, and then it basically divides with the mirrored write transaction, which is again also a cumulative value, and that way you see an kind of a difference. But yeah, you can use this TSQL and then look at and then get an average value. And if you feel like there is a latency, and if you're seeing that HADR sync commit is at the top of your wait types, then you can use this particular method, wherein you can add these two counters directly on the performance monitor and then have a look, or you can schedule this, maybe like create it using a data collector set, and then you can look at the data at a later time to see like what is the transaction latency at that point in time. That way you will be able to clearly understand where is the transaction delay, and then you will be able to pick it up. So that's it for this video. I will be discussing about like how to find where the HADR sync commit wait type issue is. For example, on which layer, whether it is going to be on the disk, or is it on the network, or is it the transaction that is having issues. All these things will be discussed on a separate video. But for this video, this is the information. I hope you guys liked it. Have a great day. Bye.